Hi, my name is Cyril Brunner, Innovation and Technology Leader at Vermont Electric Cooperative. We recently deployed Edge Zero sensors on our distribution system. We're super excited to be getting voltage data back. Our AMI system does not deliver that voltage data. And in the past, we've been super reactive to issues that we discover. And this now enables us to be much more proactive. A great example of that is we recently found a transformer that had a bad leg. We went out, we replaced that transformer, we avoided an outage, and we also, enabled that member to continue their work without being negatively impacted. BC is engaged with several national labs and the University of Vermont on use-inspired research. This research is really critical to allowing us to bridge the, reliability and affordability gaps that exist in the energy transition. And we're really excited to be working with Edge Zero on their PowerMap dashboard. That dashboard is going to enable data from the Edge Zero sensors to be accessible by research institutions. That allows them to validate engineering models. It allows them to do more work on analysis that we're just not capable of doing because we're a small cooperative with a limited staff. We're also really excited that that tool is going to enable other co-ops to see what sort of data you can collect, what that looks like, gives folks a sense as we continue to try and collaborate with other co-ops across the industry and continue to meet those cooperative principles.
Thanks, Cyril. Appreciate those kind words, and we absolutely enjoy the fact that we are working with such a good partner. For those of you who don't know me, I'm JT Thompson, Chief Revenue Officer here at Edge Zero and leading the business here in North America. And I've been asked at this part of the webinar to really spend a few minutes to kind of tell you how we got here and give you kind of a little bit of a precursor to the demo that you're going to be going through here in a few minutes. So let's talk about it, right? De-risking the energy transit in the energy transition, right? So the first question that I want you to think about is, are you protecting one of your most critical assets, the distribution transformer? And you might be thinking, okay, JT, why are we talking about this? And why are you why the question? Well, we've all heard it, right? I mean, it's been the three largest trends that I've heard about in the last 4 conferences that I've gone to, right? Transmission, getting it from all these renewable, developments that are going on across the country, and the 2x in the, amount of generations in the queue compared to what we have now, and the fact that we're trying to electrify everything, EV, and the fact that load growth is going through the roof all because of data centers and AI, right? But no one seems to be talking about the distribution system. And let's be real, right? With the distribution system, there are challenges that we have to be thinking about, right? Just outright OpEx and controlling voltage, wildfires for all of our friends on the West Coast that have to go through that struggle every year. People are still trying to wrap their heads around how to implement 2222. Always trying to keep our customer satisfaction numbers up, and SAIDI and SAFE. And we haven't even talked about the fact that there are long lead times with transformers. So if one goes out and you don't have a full supply, you might be waiting a while. And then you've got the fact that there's state issued mandates around really driving more solar and EV adoption. And we ain't even started to talk about AMI 2.0 and what it is or isn't. So here's a question, right? Second question, are there some lessons that we could learn? And actually, the short answer is yes. We've been around for a while and have had some projects all over the world, right? As you can see here. But for the next couple minutes, I want us to focus on that beautiful continent in the Southern Hemisphere known as Australia. Got some awesome animals, some great people, and some really cool technology and things going on down there. So to really summarize Australia and what's been going on, it really starts with this simple fact. It's all about forecasts gone wrong. Dial back to 2015. AMO, which is the Australian Energy Market Operator, forecasted that by 2023 there'd be 10,000, gigawatt hours of rooftop solar. When we got to 2023, there was 3x that. A little bit of a problem on the end of forecasting. Fast forward a little bit to 2022. This same organization put out a forecast that said, hey, by 2030, we're going to have 12% EV adoption. Came back out and said, you know what, last year we were actually, we need to bump that forecast up. So they went from 12% to 21% in just a year's time. So needless to say, the forecasts have gone wrong. And what happened? Like what began to be the problem? Well, first and foremost, they weren't able to see the impacts that this under forecasting and this evolution and increase in penetration in both primarily solar, but now EV was having on the distribution system. So along came Edge. And what we've done is we've begun working with 7 and well now 8 of the major distribution system operators within the country. And their whole purpose was first and foremost to gain visibility at what's going on that last mile, right? Because it's that last mile that really becomes the choke point. What's happening with that can on the pole or that can on the pad out there that is, is it overloaded? Is it underloaded? Is it overvoltage? Is it undervoltage, right? And so that was step one. And for several of them now, they have rate-based this and are now moving to large-scale rollouts, and in some cases having at least one monitor for every 75 customers that they serve. So what have been the results though, right? Okay, so they put monitors in, JT. What's the result? Well, you can see for yourself here, but I'll highlight just a couple of them, right? First and foremost, really with Endeavor, being able to actually show an MPV of over $55 million through a low voltage grid scale rollout of our monitors in their system, right? Through voltage management, phase balancing, etc. The other one is I'd like to point out is our friends at SA Power Networks, where they're experiencing a $3.5 million a year OPEX savings. You got Essential with the $10 million in upgrade, avoided infrastructure costs. And the one that I find just absolutely phenomenal and just really, really cool was the fact that, again, our friends at Endeavor used the technology to better understand how they could go and reduce their CapEx on an electric bus depot connection from $6.5 million down to $2.5 million, all through understanding what was happening around the place where they were going to go and electrify the bus depot. So, proof's in the pudding, numbers are there, and we've done some really good work. One last thing though, before we move on to a little bit about the technology as a precursor to Amanda diving into the actual platform, I want you to consider this. Just recently, on July 29th at 6 o'clock local time, 4 of the major points on the Australian energy market hit price spikes that in US dollars would be about $1,000 either side of $10,000 a megawatt hour. Now, there were 2 reasons for this. One was that there was one primary transmission line that went down, but the other, just as important issue, was that it was 2 degrees C, so it was cold, right there in wintertime, and there was a huge increase in heating load at that time of evening when people were coming home. So this made me sit there and think about this, right? Say you're a person who owns a battery system, or hey, you got one of those new Ford F-150 Lightning saying you're ready to do V2G. But you know what? You can't take advantage of this price spike. You can't even, you're not able to monetize off the investments that you've made in those distributed energy resources. And why? Because it just so happens that there's a congestion issue on your local distribution system that's not going to allow you to participate in this wholesale market. Just something to think about. So, what about the technology? Well, the technology is a combination of both hardware and software, and the applications are far reaching, right? It's more than just operations, right? Being able to actually see what's going on the last mile and the blind spots that you have on your system today. The data even helps with planning, with resource planning and asset management, knowing when you should be able to start thinking about when you're going to replace certain parts of your system. Can even help with interconnection requests and being able to streamline that so you can get more DERs on your system. And from a future grid perspective, right, that interconnection request, it's all about sitting there having the ability to get more assets onto the grid in a safe and reliable fashion. So let's break that down. First, the hardware, right? It's a lot of pieces here, but the way I like to say it is that, yes, there's the versatile and the protected and the secure, but really it's a small, compact hardware, piece of hardware that is truly versatile in both the way it can communicate through 4G LTE or LoRaWAN mesh, as well as the fact that it's a set and forget with a 15-year asset life. So once it's on the pole, that's good. And I think the thing that goes really, under the radar is the ease of installation. An individual in a bucket truck, a line worker, can actually get this unit, a unit, installed in under 30 minutes, and we even give them an app to commission it remote. It's secure, it's protected, and it's pulling back all the power quality data every 60 seconds. So where does that data go? Well, it goes into the Edge connected platform. And the way I like to say it is that this is really like taking Google Maps and putting all your power quality data on it, right? It's truly a wonderful visual display of what's really happening. And for people like me that, need simple things, you can see very simplistically what is going on your system on a couple of different levels. But what I also like about this platform, and we'll see in the demo, is that you can go as wide and as deep as you want on the data that we're collecting. So that's it for me. That's kind of a quick overview. So at this point, I'm going to pass the baton off to our Vice President of Sales and Strategy, and a person I have worked with on multiple occasions over the years, Miss Amanda Frike. Take it away, Amanda.
Great. Thanks so much, JT. It's a pleasure to be here, and I am thrilled to be sharing the Edge Zero platform with everyone. So with that, I'm going to go ahead and share my screen. And we will go ahead and start in the live grid map that's provided in the platform. And what you see here is this is an overview of all of the assets represented in a geographical way, right, on your map of your system. And each one of those little spikes is a distribution transformer monitoring solution. So that's a grid logger out there. And what we've done here is we can color code them based on a few different metrics. So out of the box, the default is KVA loading, which is what I've switched it to here. And you can see at the bottom that what these colors represent. So we can say if they're under load, if it's critical load, if they're overloaded. All of those bands for those definitions are completely customizable by you. So if you're someone who likes to run your system a little higher, we can move those metrics up. If you're a little more conservative, we move them down, right? The one that I like to look at a lot is the line voltage readings and then the 7-day voltage compliance. I have a background in operational engineering. We did a lot of voltage complaints and voltage work to make sure that the voltage profiles we're supplying to our customers were within the 5% IEEE standard. So that one is a particular interest of me, and we'll get back to that in a second because you can see there's a couple of outliers there. And the last one down here is power flow direction. So if you're someone who's looking at, how are DERs kind of impacting the power flow direction on my distribution transformer assets, are they experiencing a lot of that backflow? This is a really good way to look at that in real time. How is my system operating from a power flow perspective? So let's jump back to the voltage compliance. And I'm going to hop onto one of these transformers here. So let's grab this little guy who's red. You can see general information's pulled over. We have out-of-the-box APIs. We can bring in your GIS data to make sure that everything is really seamless and that your data is always kind of based back to that one source of truth. So here you can see this is a 15 kVA transformer. We're not loaded very much at all right now, a couple of percent. It's got its positive power flow, but that voltage is a little high. So we're going to go ahead and dig into this. Normally I would click view details. I'm just going to hop over on tabs for the sake of time. And you can see here that its voltage profile in the last 7 days averages at 124.5. So riding a little high, but the highest voltage is almost 127, which is out of compliance. So this is a really good indication to the engineering team to take a peek at what's going on out there, right? Do you have things like extra solar kind of raising the voltage? Is there something going on with the transformer itself? Do you have a capacitor that's stuck on that shouldn't be? There's a lot of different reasons this can happen, right? But at least now you know that it's happening and you can go address the issue. On this same live summary page that we're on now, I want to scroll down. You can see different metrics, and there's a lot of different graphs and representations of data available. We won't go through all of them because we'd be here for a long time, but I want to hit a few highlights. One is what you've got this last 30-minute data readings chart down here. This is interval data that can be especially useful if you are an engineer digging into kind of situational awareness and what's happening in real time, which is exportable to CSV. So if you want to pull it out onto your computer, manipulate it with maybe some other data you have, this is how you're going to do that. Scrolling back up, let's go over to the data analysis tab. So our partners over at VEC, this is their favorite tab, right? This is where they can really dive into the different power quality metrics on that singular grid logger representing that individual asset of the distribution transformer. So you can see here right now, we're looking at a singular day on 5-minute data and we're set to current. Let's say I actually wanted to look at the voltage profile. I just click over here, I can click on voltage and you can see there's all these different measurements that we're taking that you can put through onto this graphical screen and have a look at. So for your engineers out there, this is a great place to really dive into what's going on with your asset. So you've got all those graphs here. And then I also want to show the hosting capacity. So this is a really interesting place to go if you're thinking about how can I put more EVs on the grid? How can I allow more solar penetration in certain areas? Really looking at how can we optimize where to put battery storage or maybe deploy a VPP. And this lets you go down to the asset level and calculate how much can I put on this transformer. So for example, if I'm sitting at this 15 kVA transformer, right, and I want to put on a level 2 charger, I'm going to have a 7 kilowatt hour single phase charge rate. Let's say I want to do it for 4 hours. I'm going to do it in the evening at max EV capacity. Okay, then I can put 2 on pretty much all day. And it lets me know, okay, as long as it's only 2 customers or 2 vehicles, we're going to be fine. But if we start switching some of these things, like we'll say it's at peak, maybe it's an 8-hour charge, and we calculate, this data could start to change, right? So now at 8 p.m., we can only allow 1 vehicle. And you can run through these different scenarios to take a look at how are these assets going to be impacting your transformer, and is it going to be safe to run things as these cars are coming on the system? So this is really fun to play around with if you are an operational engineer, if you're concerned about hosting capacity in certain areas, if you're, again, optimizing things like VPPs or DERMS deployments, using something like this to calculate can be extremely helpful. Other things that are available, you can forecast load in here, you can check out event logs, you can capture imagery, so actual pictures of every installation of the grid loggers onto your transformers right in the system. Again, if you want more information, we would love to give you a demo and really hit home the different things that are meaningful to you and your utility or organization. And with that, I do want to invite you to join us in the VEC sandbox that we've built. So this is our partners in Vermont have graciously given over their data and their live access to their platform. We've kind of stripped out some of the more confidential information. But this will be publicly available to utility folks, national labs, educational situations, like anyone who really could find value out of learning from real system data at the distribution transformer level is invited to come join us in what we're calling the PowerMap. So there'll be a link below to join us there. We hope to see you over there. If you have any questions, please let us know. But thank you so much for joining us, and we hope that we will talk to you soon.